sum of the first 25 terms of the arithmetic sequence -12, -16, -20, and so on. In this problem, our first term, a sub 1, equals -12. The common difference is -4, because -12 minus 4 is -16, and so on. N is equal to 25, because we're looking for the sum of the first 25 terms. So the question is, what is S25, or what is the sum of the first 25 terms? When we do not know the last term, the formula that we can use is S sub n equals n over 2 times the quantity to a sub 1 plus quantity n minus 1 times d. So, therefore, S sub 25 is equal to 25 over 2 times 2, a sub 1 is -12 plus n 25 minus 1 times d, -4. Since 25 is not divisible by 2, you can leave it as is for the meantime. Let's work on inside the parentheses. 2 times -12 is -24. Then plus 25 minus 1 is 24 times -4. Then just copy 25 over 2. This is -24. Then 24 times -4 is -96. Therefore, S sub 25 is equal to 25 over 2 times -120, and simplifying, we will get, now 120 is now divisible by 2, so 120 divided by 2 is 60. Then 25 times 60 is 1,500. And positive times negative is, of course, negative. Find the sum of the even integers between 1 and 101. Between 1 and 101, the even integers are 2, 4, 6, 8, 10, and so on, up to 100. This means to say that in this sequence, a sub 1 equals 2. The common difference is 2. N is equal to 50. From 2 up to 100, there are 50 numbers. Now we are asked to find the sum of these 50 numbers. Of course, our last term is 100. We are asked to find the sum of these 50 numbers. So S sub 50. Since we know the first term and the last term, and we also know how many terms are there or how many numbers are there, we can use the formula S sub n equals n over 2 times first term plus last term. So S sub 50 is equal to 50 over 2 times first term 2 plus last term 100. 50 is divisible by 2. We can divide. This is 25. 2 plus 100 is 102. Then 25 times 102 is 2,550. So this is the sum of the 50 even integers between 1 and 101. Find the sum. 2/3 plus 5/3 plus 8/3 plus and so on plus 20 over 3 plus 23 over 3. Now, since 20 over 3 is somewhat near to 8 over 3, we can deduce the missing terms. the missing terms will be 11 over 3. Then, okay, so we are adding 3 to the numerator. As you can see, we have 14 over 3, then followed by 17 over 3. Then after 17 over 3, that will be 20 over 3, then 23 over 3. Now we can do that because somehow the numbers here are kind of small. Okay. Thus, our first term, a sub 1, is 2/3. Our last term, a sub 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms. Our a sub n or a sub 8 is 23 over 3. The common difference is denominator is not changing, but the numerator increases by 3. That means that we are constantly adding here 3 over 3, or simply 1. Again, we have 8 terms. N is equal to 8. And the question is, what is the sum of these 8 terms? Since we know the first term, the last term, and the number of terms, then we can use the shorter formula. That is, S sub n equals n over 2 times a sub 1 plus a sub n. So S sub 8 is equal to 8 over 2 times a sub 1, 2/3, plus a sub n, the last term, is 23 over 3. 8 is divisible by 2, and that is 4. 2/3 plus 23 over 3 is 25 over 3. 25 is not divisible by 3, so we proceed to multiply. 4 times 25 is 100 over 3. So S sub 8 is 100 over 3, or this is also equal to 33 and 1/3, or we can have it in decimal, 33.33. It will of course depend on the choices in the exam that you're taking. Now, what if for example, the terms in the sequence are not that obvious? Now, suppose you have a similar problem, but then it is not easy to give the missing terms. Okay? So what you will do is, to find the value of n, you must know the value of n. Okay? So what you will do is, you know that a sub 1 equals 2/3, then a sub n equals 23 over 3. Then you also know that the common difference is 3 over 3 or 1. So you must know the value of n. So you're going back to the formula of a sub n, which is a sub 1 plus n minus 1 times d. That is 23 over 3 equals a sub 1, 2/3, plus n minus 1, you don't know n, times d, which is 1. Let's transpose 2/3. That will be 23 over 3 minus 2/3 equals n minus 1 times 1 is n minus 1. Then 23 over 3 minus 2/3 is 21 over 3 is n minus 1. Then 21 divided by 3 is 7 equals n minus 1. Therefore, 7 minus, okay, we have minus 1 at the right. That will be 7 plus 1 equals n. So n is equal to 8. Now, after solving for n is equal to 8, then you can proceed to this formula. Okay, you can use this formula. Yeah. So you're going to do that if the missing terms are, let's say, there are several missing terms, and it would be tedious to write all the terms. So you're going to solve for n. After solving for n, then you can use this formula. Now, will you try this? Try the next one. Find the sum of all the integers from 1 to 100.